looking at absolute value equations now. Here's an example. We have the absolute value of 5y minus 1 in absolute value bars minus 7 equals 4. How do we solve these absolute value equations? Well, the first step is to isolate the absolute value bars. In other words, the expression that has the absolute value has to be isolated by itself on either side of the equations. So for us to make this happen, which would mean we have a minus 7 here, the 7's got to go. It's got to go to the other side. We're adding 7. That leaves me with the absolute value of 5y minus 1 equals 11. And now, just then, you can now solve this equation by rewriting it into two problems. You have to rewrite an absolute value equation into two problems, one that is equal to the number we have on the right-hand side, and the other equation which is equal to the negative number. Because absolute values, if you recall, a really quick review here, the absolute value of x equals 4, for example, which two values make this a true statement? Well, we can say x is equal to 4 because the absolute value of 4 is equal to 4. But we can also say that x is equal to negative 4. Why is that? Because the absolute value of negative 4 is also a positive 4. The absolute value is a distance problem. Distance from 0, distance is positive. So now I'm going to rewrite this problem without the absolute value bars. This becomes 5y minus 1 equals 11. That's my first problem. And the second problem would be 5y minus 1 equals negative 11. Now we solve this equation just like we would solve any other equation. Add 1 to both sides. 5y equals 12. Divide by 5. And yes, again, our answer is a fraction, which is 12 over 5. Beautiful. Now on the other side, we're solving plus 1 plus 1. 5y, negative 11 plus 1 is a negative 10. Divide by 5. Negative 10 divided by 5, y is equal to negative 2. So we have two solutions. Again, if we check them, they both will make this absolute value equation a true statement. And when we have absolute value equations, we like to write the solution like that. Negative 2 with, I call them fancy braces, negative 2, comma, 12 over 5. Here you go. That is how you solve an absolute value equation. Now we're looking at absolute value inequalities. Absolute value inequalities, again, the difference between the inequality and the absolute value equation is the symbol. Absolute value equations have an equal sign. Inequalities have our inequality symbols. So here we get the absolute value of 3x plus 1 is greater than 5. Similar to equations, we have to rewrite this problem into two inequalities. The first one would be 3x plus 1 is greater than 5. And the second equation is 3x plus 1 is less than negative 5. Absolute values, we can have two answers. One positive, one negative. However, when we take it out of the absolute value bars, it will be positive, and hopefully we have the right answer. So let's take a look here. We're subtracting 1. 3x is greater than 5 minus 1 is 4. Divide by 3. and x is greater to 4/3. Now, from previous work, you know that when we have absolute value inequalities that have the greater symbol in between, that turns into a compound inequalities with the word or in between. Let's solve the other inequality, -1 minus 1. 3x is less than -6. -5 minus 1 is -6. Divide by 3, which leaves me with x less than -6 divided by 3 is -2. So these are my two inequalities, and in between I have an or statement. I can again visually show this by using the number line. Let's say over here is -2, and here we have 4/3. So x is greater than 4/3. 4/3 is not included, which means I need a parentheses. My inequality points to the right, my error is going to the right. X is less than -2, less than, pointing to the left, parentheses, because we don't have an equal. In interval notation, two parts. Two-part interval notation. We start on the left-hand side, which is going to -∞, comma, -2, parentheses, union for or 4/3 to, where do we end up? At infinity. So when we have an absolute value inequality that has a greater symbol in between, what happens is it turns into an or problem. We solve the two inequalities, and then we write our solution according to our number line. Now here we have the absolute value of 2x minus 4. This time is less than 7. We rewrite the problem again. We have 2x minus 5 is less than 7, and 2x minus 5 is greater than -7. So we're changing the inequality and we're making the number negative. If we solve it, we add 5. 2x less than 12, 12, divide by 2, x is less than 6. Now with a less than inequality and an absolute value, our compound word we need in between in this case is and. We solve this inequality. 2x is greater than -2. Divide by 2. X is greater than -2 divided by 2 would be a -1. So x is less than 6 and greater than -1. Usually we say the -1 first. The order is not that important as long as you have the correct number line. Of course, -1 is on the left-hand side and 6 is right here. So our solution really means we are between -1 and 6, and they both call for parentheses. There you go, between -1 and 6. As an interval notation, we get parentheses -1 comma 6. Done you are. This completes how to solve absolute value inequalities.